Well, hello there. Welcome to today's discussion on dependent events. We are going to continue our discussion on probability of compound events today by looking at situations where not replacing items, how it affects the overall probability of two events occurring. I want to first give a shout out to my good friend Ann Dunn, who shared these notes with me, though I am placing my voice or integrating my voice with these notes. She's the one that put them together, so I didn't want to continue without giving her a little shout out. So first, let's look at some vocabulary. When you look at word problems or problems that involve dependent events, you're going to see vocabulary words like not replaced, one at a time. So in other words, you pull something out of a bag and then you pull something else out of a bag one at a time. It's assumed that you don't replace the first. Event and outcome. An event is any occurrence that happens in regards to probability, like rolling a die or flipping a coin or pulling a marble out of a bag. And then the outcome. The total number of outcomes are all the possibilities, and our probability of a specific event occurring would be our desired outcome, or the ratio of our desired outcome over the total number of outcomes. Events are dependent, that's a fill-in, if the outcome of one event affects the outcome of another. For example, if you draw two colored balls from a bag and the first ball is not replaced before you draw the second ball, then the outcome of the second draw will be affected by the outcome of the first. So in other words, if you had 10 balls in a bag, if you pulled one out and didn't replace it, the probability is now not out of 10 possibilities, but out of 9 possibilities because you took one item out of the bag. Sometimes one event can affect the outcome of another. For example, there are 5 marbles in a bag. 4 are blue and 1 is red. If a marble is selected at random from the bag and not replaced back in the bag, there's that phrase, not replaced, the chance of drawing the red marble will keep increasing with each consecutive draw. So even though, and this first row represents all the possibilities before we even begin, you have 5 balls, 1 of them are red. Well, if I pull a blue out of the bag, now there's only 3 blue remaining, and there's still that 1 red. But then the next time I draw, so this is now my third attempt, I have 1 less blue, so now I have 2 blues and my 1 red. And so all the way, if this continues down to our 5th trial, if we haven't pulled that red ball out, we have a 100% of pulling this red ball, even though we started out with only 1/5 out of the balls being red. So let's look at some examples. There are 3 orange candies left in a bag of multicolored candies with a total of 20 candies left in it. So I'm going to underline some phrases. 3 orange, 20 candies. The probability that you will get an orange one when you reach in is, well, if there are 3 orange, that's our desired outcome, over 20 total, that's the possible total outcomes, the probability of us pulling out an orange is 3 out of 20. And I'm going to enter and you'll see the same thing. But what if your chances of getting an orange if you reach in again? There are now 19 candies in the bag and only 2 are orange. Remember, 1 slide back, you pulled 1 out. So not only is there 1 less candy, there's only 19 now, there's also 1 less orange. So now your odds are 2 over 19. Taking the first candy affected the outcome of the next event. Therefore, these events are dependent. One affected the other. One outcome depends on the other. The probability of drawing 2 candies and both will be orange. Here's our probability of the first. 3 out of 20 are orange. Now we took 1 out, only 2 orange remain, 19 total candies remain, and we've talked about how in order to find compound probability, 2 separate events, here's our first pool, here's our second pool, we're going to multiply the 2. I will always advise that if you can cross-reduce, remember if you look at the diagonals and we can reduce them or simplify them, we will certainly try to do that. Both numbers can be divided by 2. 2 goes into itself 1 time. 2 goes into 20 10 times. And this is something we can easily do mentally. 3 times 1 is 3. 10 times 19, 190. I would not put my money on those odds. A bag contains 6 red, 5 blue, excuse me, and 4 yellow marbles. 2 marbles are drawn, but the first marble drawn is not replaced. Those 2 words mean we've got a dependent event on our hands. So first we have to figure out how many total marbles there are. 6 plus 5 plus 4 is 15. 6 plus 5 is 11. 11 plus 4 is 15. So the first time we reach in, out of the 15 marbles, 6 of them are red. But we take 1 red away. Now there are 5 red. And not only are there now 5 reds, there are only 14 marbles in the bag. Red was affected with our first pull, so now there's only 5 red. However, we still have 5 blue marbles in the bag. So we have 5 of the 14 marbles remaining are blue. To find the compound probability of these dependent events, we're going to multiply them. I found that I could reduce 5 and 15 by dividing both 5 and 15 by 5. 6 times 1 is 6. And 6 times 14 is 42. And that can be further reduced. I can divide both 6 and 42 by 6. And finally get a simplified answer of 1/7. And this will continue to break down what we just did. There are 6 red marbles. There are a total of 15 red marbles. So the probability of red is 6 out of 15, which reduces. You can divide both 6 and 15 by 3 to 2/5. The result of the first draw did affect the probability of the second. Now there are still 5 blue marbles, but only 14 marbles left. And when we multiply those products, 10 over 70 or 1/7, we got 6 over 42, which reduced to 1/7. So let's look at a little bit of review. When the outcome of one event does not affect the outcome of a second event, that is independent. That would be like flipping a coin and then rolling a die, or pulling a marble out of a bag, replacing it, so there's still the same number of marbles in the bag, and then pulling another. When the outcome of one event does have an effect on the outcome of the second event, the events are dependent. So we'll look at just a few examples before we conclude today's notes. We're going to decide whether we have independent or dependent events on our hands. You toss a coin, then roll a number cube. Is it independent or dependent? If you said independent, you are correct, because tossing a coin has no effect on the outcome you get when you roll a number cube. What about if you choose a bracelet and put it on, then choose another bracelet? So you're not putting it back, not replacing it. Now what's left in the at the jewelry case or in the jewelry case has changed. There's one less. Therefore, these are dependent events. We'll do two more. Select a card and do not replace it. Then select another. When you don't replace it, it's dependent.
I'm sorry.
Select a card and replace it. You're putting it back. You have not changed what is in the deck. Therefore, those events are independent. Thank you very much for tuning in to today's notes. Please bring any questions you have on independent and dependent events to class tomorrow. I look forward to seeing you then.